Hello everybody, this is Jimmy and this is the fifth lesson in our course. In this lesson, I will talk in more details about the development of smart contracts in the Neo blockchain. In the last lesson, we have learned about smart contracts and decentralized applications and set up a developer environment for smart contracts development in the Neo blockchain. Before we start, I highly recommend you to watch the previous lesson because this part continues the learning of smart contracts and many things may be incomprehensible. If you are familiar with this topic, you already know that smart contracts are a kind of small applications in the blockchain that help automating various processes and open up new programming possibilities. Thanks to the blockchain, smart contracts has significant advantages with respect to conventional applications. One of the important advantages of which is the placement of the application. If you have ever been able to write code, for example, web applications, or are familiar with the algorithm of their work, then you know perfectly well that the same web server needs to be placed somewhere and at the same time take into account many different factors. The server may stop working, access to it may be restricted, it may be subject to attacks by intruders, while the secured smart contract is a decentralized application that is placed once in the blockchain and after being entered into the block remains there forever. Yes, its functionality may vary, access may be limited, but all this happens according to predefined algorithms. And not because, for example, someone has laid out a non-working code or the electricity has been turned off in the data center. Of course, this approach also has its drawbacks. For example, in order to change the code, you will have to upload a new version to the blockchain. And of course, this will be a new contract. But as a rule, smart contract developers take all these small differences into account. As we discussed in the last tutorial, smart contracts in the Neo blockchain can be written in most high-level programming languages, which is aimed at accessibility for developers. Once again, I will list the list of languages. This is C#, VB.NET, F#, Java, Kotlin, Python, Go, and JavaScript. This approach greatly facilitates the development because a person does not need to learn a completely new syntax from scratch, but to implement the desired idea with the existing knowledge. Differences in the process of writing a contract for the blockchain Neo using these languages are reduced only to differences of languages. Therefore, choosing a language, first of all, it's necessary to build on how well you know this language and how convenient and easy it will be to implement a certain logic of a smart contract. And now I would like to demonstrate how you can create a smart contract in the Neo blockchain from scratch. We will do this on the example of the NAP5 standard token contract and use the Python language for this. In the last lesson, I've mentioned that each language supported by smart contracts Neo has its own libraries and modules. And Python also has its own NeoPython client. One of the main such libraries is NeoBoa. It allows you to work with the NeoVM virtual machine and compile the code in AVM format. We will use this library in our work throughout this lesson. It comes with the NeoPython client, so if it's already installed, you don't need to download anything else. Let's start writing a smart contract. To do this, just open your favorite text editor. I will have this Emacs text editor. We will write the name we want. Let it be nap5.py. At first, let's specify the settings of the token. These are the variables that will be responsible for the operation of the token itself. These should be such variables as owner. For now, let's leave it. Also, variable is token name, and here we set the name of our token. We will set something simple, something like my first NAP token. Further, we specify the symbol parameter. It will be the short name of the token. As a rule, it consists of 4 to 8 characters, so just write NAP5. After that, we set a number of decimals. In the previous lesson, we have talked about decimals. It's the number indicating the number of decimals places in the number of tokens. That is, how much it can be divided. Set decimals equals to 8. And we set the last parameter. This is the total number of tokens that you want to release. Token total supply. And here we set the number itself. Let it be 10,000. And multiply by the number decimals. It will be 10 in the 8th power. For now we finished with the settings. Now we need to specify another very important variable that will be responsible for the context, the storage of data in the token contract. To do this, we need to take a certain function from the NeoBOA library, which is called getContext. We import from BOA interop, that is internal operation, NeoStorage imply getContext. And we specify our contexts in the variable CTX. This variable will be used quite often, especially when saving or comparing data in a contract. Now we can specify our main function. It will be called main. We indicate two function parameters that we will use. These will be the operations and args parameters. When calling a smart contract, these parameters will be transmitted. The first is responsible for the name of the operation and the second for the various function arguments. Next, we need to specify in which modes the smart contract will work. In this case, there will be two modes, verification mode and application mode. In order to divide the logic according to them, we need to specify a trigger. To do this, we need to import another function from the library. It's called getTrigger and it's located in the runtime section. After that, save the result of the function in a variable. Now we have to specify what should happen in each of the modes. We specify the verification trigger and import the verification function, which is located in the trigger type section. Together with it, we import the second application function. If the trigger is verification, then in this case we will check whether the sender of the transaction is the owner of the smart contract. To check the address of their sender, we import another function called checkWitness, which is located in the runtime section as well. After that, we specify checkWitness. If this is the owner of the smart contract, then we return true. If not, then false. We indicate the second mode of operation of the smart contract, that is application, and it can indicate the function of the smart contract itself. First, we write to switch functions and then the code of the functions themselves. According to the NAP5 standard, the token must have certain functions. One of them is the name of the function, which gives the name of the token. By the same principle, we will do this for decimals, symbol, and total supply. These were simple functions that take no additional argument values and simply give the values from the contract. We turn to more complex functions. One of the main functions of the token is to send tokens from one address to another. We will have two functions that do this, transfer and transfer from. And in these functions, it's already necessary to write a certain parameter validation. 3 arguments must come to these functions that need to be checked. The len function in Python allows you to get the number of arguments or elements in lists and strings. Therefore, we will make a check that the number of arguments is 3, and we write these arguments into variables. Arguments t_from, t_to, and t_amount, and after that we will make the transition to the internal function of the contract, to which we transfer all these parameters and context. In case if there are not 3 arguments, we return false. By the same principle, we will make the transfer form function. In the switch, it will differ little from the previous one, but in the internal logic, there will be strong differences. It allows the owner of the tokens to allow his tokens to be used by some other person from his account. There will be also 3 arguments, but with different values, and again, the transition to the internal function. Another operation is allowance, which allows you to find out how many tokens are given for use from one account to another. There will be only 2 arguments, the owner and the address to which approve was made. Now we will make another exit from the switch, which will work if the function name is entered incorrectly and give an error. And another operation, balance of, which will give the value of tokens on an account. There will be 1 argument, the address of the account, and also the transition to the internal function. Create this function immediately. Do balance of. This is a very simple function that checks the address. This can be done by checking the number of characters in the address. This can be done by checking the number of characters in the address. Since the number is centralized in the Neo blockchain, if the length of the address line is not equal to 20, then this account will be incorrect. Now we need to import the methods for working with the storage of the smart contract. These methods are get, put, delete. They are in the storage section, and we add the get function to the end of the do balance of function, which will take the value from the repository. Now you need to write another important part of the smart contract, events. In the previous lesson, I talked about the events in smart contracts. They are records that are stored in a smart contract as a result of a certain actions. In this case, these will be the onTransfer and onApprove events, which will be recorded when the transfer and approve function are called. To save events, import another register action function, which is located in the action section, and write these events. We write the name of the transfer and the parameters that will pass to this event. The from address, the to address, and the number amount, and in the same way with the approve event. We now turn to more complex functions, and the first of these will be the transfer function, which the parameters from to amount. Let's write some checks for this function. For starters, checking for an address, they must be correct for addresses from and to. Next, we check the sender of the transaction. We point out that when specifying identical addresses in the from and to functions, it does not perform any operations. Next, we take the number of tokens from this address from the smart contract and we will verify this value. If the value that is requested is greater than the number of tokens on the address, then we write there are not enough funds and give an error. Further, if the values are equal, then we will delete the value of the tokens from the smart contract, because there is no point in storing it if it's null. In another case, we calculate the difference between the values, which we ultimately save in the smart contract. Now we take from the smart contract the value of tokens on the to account, save it to a variable, add the amount to this value, and then save it to the smart contract. After that, we have to send the onTransfer event because at this stage the function worked successfully. Finally, if the sender of the transaction is not the address specified in from, then we give an error. With the doTransfer function finished, we go now to doTransferFrom function. Its difference is that it allows you to send tokens not from the address that sends the transaction, but from the other. If he was allowed to use the tokens of the address, the first three checks here will be similar. After that, we will look at the values for a specific key. To do this, we need to import another function from the library called concat, short for connection. It's in the built-ins section. We set the key to the from addresses and we combine these two addresses. And the resulting value is the key for storing the value of the number of available tokens. Take this value and check if there is enough money to transfer. If this amount is less than the parameter amount, we write that there are not enough funds. We also request a balance from the contract and verify that there is enough money on the balance of the address itself. Next, we request the balance of the person to whom we are sending. And now it's necessary to subtract this request number from the balance of the from address and add it to the balance of the address to. After that, we save all these values in a smart contract. After this transfer is completed, we write the answer and save the new value of allowance. After this transfer is completed, we write the answer and save the new value of allowance as it has decreased. And in this case, this value is 0, then simply remove it. If the remainder remains, then we calculate it and save it. It remains only to create an onTransfer event and turn true. With the do transfer from function finished, now we can write an approve function that allows a person with one address to use tokens from another address. Again, we write checks to the addresses so that they are correct. We also do a check that the address in the from parameter is the sender of the transaction. And check that the amount is greater than 0. Now we need to check that the requested amount is less than or equal to the number of tokens on the balance. To do this, take the value of the number of tokens on the balance sheet from the contract via get. Next, we prescribe the key by which the number of available tokens will be stored. And if the amount is 0, then we delete the value from the key. Otherwise, we update it. After that, we will fill the onApprove event and return true. If the check for the number of tokens fails, return false. And we will add the last function that will allow you to see the number of allowed tokens, do allowance. Here again, there will be 2 checks for addresses, and as a result, the function will return the number of tokens stored by key. Now contract can be considered completed. It has functions such as transfer, approve, allowance, and many informative functions, name, decimal, symbol, and total supply. Now we can try to deploy this contract in the blockchain. To do this, first fill in the remaining owner parameter. In the last lesson, we learned the internal address of the wallet. I remind you that in the NeoPython client, we can do this with the wallet team. To start, open the wallet, enter the password, enter the wallet command, where at the very top is the script hash value. This value is copied and pasted into a smart contract. Let's deploy this contract. To do this, copy the file to the smart contract folder of the Neo local container. This folder is a link between the computer and the container itself. After that, you can deploy the contract using the command of the SC section of the NeoPython client. First, you need to compile the contract into a file of the .avm format with the sc build command. Now we will complete deployment. Enter the sc deploy command. Specify the path that you received from the sc build command and enter the deployment parameters. We did this in the last lesson. I remind you once again that we need to specify 5 parameters, 3 of which are Boolean. The first is responsible for whether you need a smart storage contract. In this case, yes. The second parameter is responsible for whether the contract requires dynamic calls. This parameter is extremely rarely needed. And the third parameter is responsible for whether the contract can receive payments. Since we have a token, in this case we don't need it, but this parameter is necessary for some contracts, for example Crowd Sale or ICO contracts. Next, we write the input data types 0710 and the output data type is 05. After that, the NeoPython client asks to enter information about the contract. Enter them and look at the information received. We were given the parameters we just entered, the hash and the bytecode of the contract. In addition, there is information from the NeoPython client, the transaction itself that will be sent, and the amount of reserved gas. We see that the test call for the contract went successfully. 11 operations were performed. The amount of gas spent was 490 and 0.01 for additional operations. Now we enter the password from our wallet, and it seems that the verification of the transaction occurred successfully and we received the transaction hash itself. We see that the test call for the contract went successfully. 11 operations were performed. The amount of gas spent was 490 and 0.01 for additional operations. Now we enter the password from our wallet, and it seems that the verification of the transaction occurred successfully and we received the transaction hash itself. Now this lesson is completed. We wrote a smart contract token, NAP5 in Python, got acquainted with the NeoBOA library, and tried to close our smart contract to the network. Thank you for watching and see you in the next lesson.